Good evening, everyone. So today we are going to start the session. Today we'll be covering overview of oil and gas part 2. So I request everyone to mute their mics and please turn off your cameras. If you have any doubts, we'll be sharing the Quilgo link so you can ask your doubts there. So I request Srinivasan sir to take the training forward.
Good evening, participants. Okay, thank you. Good afternoon to all the participants. Now we are starting the part 2 session of oil and gas training. So we will continue with the refining and distribution, which we yesterday we saw only crude unit in a more elaborate way. Today we will go in a quick session because many other things are following now. So after refining and distribution, you will see health and health, safety, environment and fire, and major incidents. And it will be followed by your question and answer session. So today we will see hydrotreater, FCC, fluidized catalytic cracking, delayed coker, Mirox treating units, alkylation, sweetening and sulfur recovery, and hydrogen unit. These are the units normally you'll find in most of the refineries. As he said yesterday, though the processes are there, the methodologies can be different from licensor to licensor, because they will follow different methodologies, but otherwise processes are same. So that is the only difference. Then after hydrogen unit, it will be followed by oil movement and storage and transportation, because this is very important. Without that, refineries cannot function. Then power and electricity and steam. Then utility that has water, air, instrument air, nitrogen, chemicals, steams, condensate. Then effluent treatment plant. All these things are part of the refinery unit operations. Then O&M is oil operation and management, maintenance issues. In that you will find the corrosion, fouling, coking, effluent. There are so many other things associated with that. These are all common to all the plants. It's not that it's only applied to one plant. Most of the plants definitely face during new startup shutdown or during the normal operation also. Then safety, then major accidents, what can go wrong and all those things. So this is more elaborate now. Now we are coming to hydrotreating process. Why why we have to do the treatment of hydrocarbon? This is basically because the hydrocarbons generally have a lot of sulfur plus nitrogen, aromatics, sodium, all those things. These are all, and the metals also, which I was mentioning yesterday, nickel and vanadium. These are actually the poisoning things for the catalyst, for the downstream units. So in the hydrotreater, all these things will be removed by injecting hydrogen at a high temperature in the reactor in the presence of catalyst. These things will be removed in stepwise in the hydrotreater reactors. That is the main purpose of the hydrotreater. Afterwards, whatever the H2S is coming out, that will be absorbed in amine chemicals. Then that will be, the rich amine will be sent to amine treatment unit for stripping. So this is the whole thing about that. So now I will just quickly go through to hydrotreating process is used for the following reasons: to meet the product specifications, then to improve performance of the downstream catalytic units, which I was telling, FCC, reformer, isomerization, etc., to remove catalyst poisons, already mentioned, sulfur, nitrogen, residue, carbon residue, metals, and all those things. Sulfur is the most critical compound to remove. It is present in nearly all the crude oil feedstocks as sulfur mercaptans, sulfides, disulfides, polysulfides, and thiophenes. In different forms is there. And nitrogen is typically treated with the hydrogen gas and transformed into ammonia. Oxygen is reacted with the hydrogen and eliminated as water. Olefins are volatile and unstable, and they are not desirable in fuels. So olefins are transformed into stable paraffinic hydrocarbons. And metals are removed because they can deposit on catalysts and engines also. That is the downstream. So in the hydrotreating process, mainly it is a catalytic conversion process in a fixed bed reactor having catalyst. In fact, in the single reactor, we'll have different partitions. First, the feed will enter into first bed where the metals will be removed. Then it will go to the other bed, like that it will go. So inside the reactor, so that catalyst will be cobalt molybdenum supported on ammonia base, alumina base. So that is the catalyst which is having tungsten, nickel, and a mixture of oxides of cobalt, molybdenum supported by alumina base. This is the catalyst, but actual composition will not be known to us because of proprietary data. And inside the reactor, hydrogenolysis and the mild hydrocracking reactions take place to convert sulfur, nitrogen, oxygen, and other contaminants to hydrogen sulfide, ammonia, which already told earlier, in the presence of hydrogen at the elevated temperatures. The temperatures easily can go to 300 degrees. Then the operating conditions of treatment are a function of type of feed and the desulfurization levels desired in the treated product. So based on that, they will vary the severity of the operating conditions. So basically, you will remove desulfurization, denitrification, hydrocarbon saturation, and oxygen removal. These are the four four activities happening in the hydrotreating process. And whatever the H2S hydrogen sulfide is released is absorbed, which in the amine, and which will be sent to amine treatment unit. Basically, it is that. Then we will move to delayed coker process. Here, I had said earlier, the bigger molecules or heavy molecules from the vacuum residue coming from the crude column, that will be going to this coker. And because it is very heavy, under severe conditions like high temperature, the molecules will be broken, and you will get lighter hydrocarbon components, plus coke also. So that's why it is called a delayed coking, because in the furnace it is heated and the coking takes place in the coker. Is a vessel, there it happens, and as it travels from the furnace to coking vessel, this actual reaction breaking starts. So there are different types of cokers: delayed coking, which is normally a common one, and fluid coking and flexi coking. These are all different methodologies used. Basically, this coking is to break the bigger molecules. And the process is called a delayed coking, since the heat for coking is supplied to the coker feed upfront in the fired tubular heater, whereas coking takes place in the insulated drums. That is coking drums. And able to process heaviest and contaminated crudes, cokers produce no liquid residue, but yield up to 30% coke by weight. This coke is called a pet coke, a petroleum coke, and it is further processed. And nowadays they use that degasification. For that they use this coke. But this can have less ash content. Depending on the type of crude used, it may have less ash content, whatever it is. So thermal cracking produces gasoline that has a lower octane number compared to FCC. That is FCC is the fluid catalytic cracking unit. And finally, this gasoline from coker and the FCC, they are all blended, and they improve the octane number by other means, which we'll see the later in the alkylation, you will see. Free radical reactions produce straight chain alkanes from longer straight chain alkanes because isomerization of free radical is not favored. So these are the typical ones on that. And here you'll see in the diagram, it is clearly shown. The temperature is about 480 to 482 degrees, and the feed is entering into the tower, and there it is getting use the heat actually. This feed is directly coming from the crude unit, vacuum column bottom. From there it is going to the heater. Heater is here, along with a lot of steam, and it will go to the coke drums. And they keep the coke drum under pressure, 3 to 8 kg pressure. Then the conversion takes place, and whatever the gases come out, they are diverted to the fractionator, and the coke is then the coke settles at the bottom. Practically, they have to break it, putting a lot of steam and all. It's a laborious process. So this is because the furnace has to run continuously. They have to switch over the coke drum from A to B or B to A, like that. And here also you get H2S, that is again absorbed in the treating, and that rich amine goes to ATP, like that. Here also you get gas oils, and these oils also, they are fed into FCC. Now we are coming to fluidized catalytic cracking process. This is one of the main process in the refinery. Here also, the bigger molecules are broken into smaller ones in the presence of catalyst, which is in a fluid state. Because though it is a solid, as it moves, it behaves like a fluid. That's why it is called a fluidized catalytic cracking. And at a high temperature, the reaction takes place there. So it's a catalytic cracking process. Cracking is the process for conversion of bigger hydrocarbon molecules to smaller hydrocarbon molecules by raising temperature and pressure. Cracking unit operates under less severe conditions than thermal coking, that is coker. It's a process for conversion of vacuum distillates coming from vacuum column, which had come through hydrotreating unit. So this will have very less sulfur and metals to more valuable lighter products. So this is accomplished by cracking the vaporized feed over a solid catalyst, silica alumina. That is this one general thing of the catalyst at a temperature of 470 degrees to 550 degrees, depending on the requirement. If you can increase or decrease based on your requirement of the products. That is the thing. And a pressure between 0.5 to 1.5 kg. The catalyst promotes reactions which lead to a better product selectivity as compared with that of thermal cracking. Cracking of petroleum yields are light oils, middle range oils used in diesel, and heavy oils also, and plus coke, and plus you get lighter products like propylene, butylene, all those things. Here, one thing to mention. So I have said coke. This coke gets deposited on the catalyst because the catalyst will be moving from reactor to regenerator, like that, because the catalyst has to be regenerated. You cannot just throw it. The catalyst gets deposited, coke that gets deposited on the catalyst, so it loses its uh, capacity to crack. So the coke has to be removed. How it is done? It is actually heated in the regenerator in the presence of air. So the coke gets converted into carbon dioxide or carbon monoxide, and catalyst gets rejuvenated, and that catalyst again comes back to the reactor. So this circulation is happening through like this. This is the reactor, blue one, and the pink one is the regenerator. And these two are connected by means of lines having slide valves. This is very important. The slide valves are the ones which are segregating this reactor from the regenerator. So regenerated catalyst flows from regenerator to reactor, and coke deposited catalyst, which has lost its capacity to crack, that flows from reactor to regenerator for further rejuvenation. This is the process, and from the reactor, the top side cyclones are there. Even the regenerator also, cyclones are provided, because otherwise what will happen, the entire catalyst will flow out. So to prevent that, the cyclones are provided to trap this catalyst and they will fall back. So through these cyclones in the reactor, the hot gases, hydrocarbon gases, they go from the top of the reactor, they go into the fractionator. From the fractionator is nothing but a distillation column, and here you get from the top side gas and gasoline, and this is more valuable, and the LCO, HCO hydrocarbons, and decanted oil. These are all in the diesel range. They can be blended. So the reactor feed here is coming at the temperature of about 300 degrees. And here the reactor, when it is rising, because the catalyst is coming and it is allowed to rise. During the when it is rising, the feed is allowed to mix with that. So when it goes up, that reaction is getting complete, because there are different variations of this FCC. I'm telling only one particular thing. When it reaches the top of the pipe itself, the reaction is complete. Then the catalyst flows out. Then it starts the circulation. So this is the thing. And regenerator is operated in the range of 1300 to 1400 degree Fahrenheit. And air is supplied from the bottom, and due to the high temperature and the oxygen availability, coke gets heated, is burnt rather. The flue gases, whatever is coming, is going through CO boiler, where the water is converted to steam. And still, whatever the catalyst is coming, that is also trapped. That because you cannot allow the flue gas with catalyst to atmosphere, because it is it will cause pollution problems. So that will again trap. So this is the whole thing about the FCC. And the reactions taking place, these are all the paraffins cracking. So it is cracked into paraffins and olefins. And on olefins, different reactions are taking, the cracking, cyclization, like that. And here you get LPG, olefins, naphthenes, branched olefins, like that. And on the naphthenes, again they crack and get cracked after cracking, dehydrogenation, isomerization, all those things. You get the products, olefins, cycloolefins, naphthenes. Then the aromatics again, it's a side chain cracking. It is unsubstituted aromatics only, because mainly it is aromatics pass through this, and different alkyl aromatics. So this is the reaction happening in the FCC. Now we will move to Marox treating process. Here, this is called the sweetening process. This Marox treatment is required because most of the hydrocarbons, they have sulfur in one form or other. So especially propane, butane, then LPG, all these things, they have sulfur, kerosene. So this sulfur has to be removed. Once, what we have seen in hydrotreater is one way of removing sulfur. There is another way of Marox treatment is another way of treating. So here the reaction takes place in different stages. First, it is allowed to pass through caustic tower. Here H2S is removed. The H2S mixes with sodium hydroxide. So you get water plus sodium sulfate. Then again extraction takes place. So R is the any hydrocarbon compound. SH is that radical. So in that S is the sulfur. So here again this reaction takes place to 2RSH plus 2NaSH becomes 2Na sodium, of course, sulfur and the R plus 2H2O. So because in this reaction more water is formed, so sodium hydroxide becomes diluted in this. And this whole reaction takes place in the presence of Marox catalyst. That's why the name has come. Marox is mercaptan and oxidation. This is the thing. So the oxidation state 2NaSr plus 0.5 oxygen, because this reaction will take place by injecting air. So RSSR, this is purely hydrocarbon only, and 2NaOH. So you get sodium hydroxide. Though you are getting, but it is in a very dilute form. So often they have to replenish with the new fresh sodium hydroxide. And some places they treat this material and get back the sodium hydroxide, which is again allowed to pass through this cycle. So that cycle becomes complete. So the overall reaction will be 2RSH plus 0.5 H2O. Use 2 RSSR plus H2O. This will be the overall reaction. So now we are moving to alkylation. Alkylation process produces a high octane gasoline, a blending component called alkylate, by reacting light olefins, mainly propylene and butylene. You can see in the chemistry view, the alkylation process converts the propylene, butylene, and pentane and isobutane to alkene liquids such as isoheptane and isooctane. The catalyst is in a very highly acidic form. So you can see in the right side is given in the presence of a highly acidic catalyst. You can use sulfuric acid, or in other processes hydrofluoric acid also used. But using hydrofluoric acid is more difficult because it has got a lot of safety considerations. So this is the thing. But of course, different process methodologies are there. The reaction is carried out from 2 to 7 degree centigrade only, that is 35 to 45 degree Fahrenheit in 2 phases. So the reaction is exothermic. So they use the lighter component itself to reduce the temperature. It comes to a cryogenic phase, and that's how the temperature is controlled. That's why cooling is required. The liquid fraction of this mixture, known as alkylate, mainly contains isooctane, a compound that lends excellent anti-knock characteristics to gasoline. So the octane number of the alkylates produce range from 85 to 95. Now I'll tell something about the octane number. The petrol, whatever in the market, whatever you get, it is about 87 octane number. More the octane number, lesser the knocking. Because when you run the vehicle, if the octane number is less, then the engine finds it difficult to function. So you get the knocking. So many of you must have experienced, those who are driving must have experienced. It can happen sometimes because lesser octane numbers, these ones are used. But of course, now government has put the restrictions, so they cannot sell lesser octane number. That is the only thing. Okay, this is the importance of octane number and connecting with the anti-knocking. Now we are moving to hydrogen generation process. Why hydrogen is required for refinery? Because many of the reaction plants, they use hydrogen. Whether you take a hydrotreater or hydrocracker, isomerization, all these places you get, they will require hydrogen. So hydrogen is very much required for refinery operation. That's why they have the hydrogen generation plant. So now, how the reaction generation is taking place? They generally use very light hydrocarbon like a methane, and this methane has some impurities. The impurities have to be removed first before going for the regeneration or in the generation, the reformer. So first they do the pre-treatment. So that again RSH plus H2, because they have the hydrogen, they can very well use that, and they get RH plus H2O. H2O is nothing but water. So here sulfur is removed first in this pre-treatment, then chlorides also removed. So 2HCl becomes 2KCl, potassium chloride, plus H2O, again water, and carbon monoxide, CO. And the third one is you get H2S. Here first thing is RSH, mercaptan. The second one is the H2S also is there. So the H2 is also removed by using zinc oxide, because zinc can easily react with the H2S, form zinc sulfide. So H2S again comes. So this is the pre-treatment. So the cleaned hydrocarbon, light hydrocarbon, is allowed to go through the reformer. The pre-treatment happens in the presence of cobalt molybdenum catalyst or nickel molybdenum catalyst at the temperature of about 380 degrees centigrade. And in the reforming, you are using nickel catalyst at the temperature of 800 to 950 degrees. It varies. So CH4 is methane plus H2O plus heat. Heat has to be given because this is the endothermic reaction. So you gets converted to CO plus 3 molecules of hydrogen you get. And the carbon monoxide, CO, is again reacting with the water, H2O, becomes carbon dioxide, plus you get one molecule of hydrogen. So ultimately you get 4 molecules of hydrogen in this reaction. Plus it generates heat also, because here it is exothermic. So this is the reaction taking place general. And the bottom I have given heat treatment, feedstock hydrogenation, chlorination, and desulfurization. And the reforming, pre-reforming, it is option, of course, and steam reforming, and carbon monoxide, shift conversion. The last one, whatever you saw, that is called the shift conversion. And now you got the hydrogen, but it has to be purified. It may have some impurities. So the receiving plants cannot accept that. That's the reason the hydrogen is allowed to pass through PSA, pressure swing unit, pressure swing absorber. It absorbs the impurities, and clean hydrogen is allowed to go out. And this operation happens at a low temperature and a high pressure. And again, like a coker, there are A and B type. So when one is in operation, the other one is under regeneration, like that. They keep on swinging. And here when you go through this process, catalytic fuel is not able to see this. The process, you can clearly see whatever I explained. All these things are in the diagram. And distribution also is given at the top. It is going to different various units, hydrocracker and other units. They are distributed, isomerization unit, catalytic reformer, all these places. And another thing is, this hydrogen, whatever is there coming out, it is coming maybe at 36 kg pressure. But some plants, they may ask, call for higher pressure, so they use hydrogen compressor. So the pressure is increased to 90 kg, like that. So depending on the requirement. Then we come to amine treatment and sulfur recovery process. They are together actually. The amine treatment, as you have seen earlier, from the different units, you get a rich amine, and they all send it to amine treatment unit, and there it is allowed to. Here also, whatever sour gas is coming at, that is allowed to pass through, and you get further rich amine at the bottom, and sweet gas, that is without H2S, that goes from the top, and the rich amine is allowed to pass through the heat exchangers, and this is the stripper where it is allowed to regenerate that amine, because it has absorbed a lot of H2S that has to be removed. So here, this is what is happening. And here you can see the absorber is operating at the pressure range of temperature range of 35 to 50 degrees and 5 to 20.5 atmosphere of absolute pressure. And the regenerator 115 to 126, because these temperatures are very important. You cannot play around much on this. Otherwise, the stripping action will not take place effectively. Sometimes what happens, along with this, some hydrocarbon comes, and it can cause some sort of foaming in the trace. So these are all operational issues. So they tackle day in and day out. So that from the top, H2S and the carbon dioxide go, they are called together acid gas. This I mentioned yesterday also, the extraction the field. This acid gas comes to sulfur unit, sulfur recovery unit, and here generally Claus process is used generally, but there are other forms also. Here this H2S is basically burnt with oxygen and converted into sulfur dioxide plus water, and in the presence of the reactor, in the presence of catalyst, it is getting converted to sulfur. So the converter inlet must be 450 degree Fahrenheit. That is important, and dew point of sulfur. And condenser outlet must be 350 degrees. So if you see in the diagram, you can very clearly see the feed is entering and it's actually burnt with in the presence of air, and it is going through different vessels where the reactors are there, 380, 305, 225, 200 degrees. and it is allowed to pass through, and it is reduced, and sulfur forms, and this sulfur is getting collected and goes to the pit. So this is how the sulfur gets recovered, and still from the third stage, there may be some H2S or some gaseous compounds having some sulfur, so they get again trapped in the tail gas unit, and that is again captured. So finally, whatever goes out, it will be only gas without any sulfur. That is the whole thing about that. The bottom again reactions are given. The last one is CH4 plus 4 is CS2 plus 2H2. So this is the reaction which is happening, and here it is getting basically here the sulfur is removed from the H2S and captured, and balance goes out. That is the only thing. And this reaction is because it is a exothermic reaction. A lot of steam is generated, and this unit generates good amount of steam. Now we are moving to oil movement and storage transportation. Whatever the product comes and crude comes, it has to go through this particular unit. Here there is no process per se, but they store it and distribute. They store it and send the process units, or from the process units they receive the product and distribute to the consumers. This is the main thing. And here you have a lot of so many storage tanks of different requirement. It may be for LPG, or it may be for gasoline, or it may be for diesel, or it may be for vacuum residue, like that. Intermediate products also. Plus, have a lot of tanks storing crude. Then they do the loading and unloading process, because you can see tankers are there and pipelines are there. So all these things will happen, and they do have the blending operation. So because from here the products are going out, so the products, whatever is going from here, this particular section, it has to meet the market demand or the parameters postulated by government. So they have to meet those things. For that, blending operations are there. They inject certain additives to ensure that they are coming within that product process parameters. Supplying to units by pumping, all these things are happening by pumping only, and supplying to customers, which I already said. And the supply and receiving and distribution takes place either by ships or train or trucks. All these things are metered. Without metering, nothing will move, because it will be a dead loss. So each and every drop of hydrocarbon will be accounted for. Here the diagram, what you can see is TG101 is one crude tank. The other 102 is another crude tank. Like that, there can be several things. TG tank 101, 102, they are all interconnected. But this man, the operation man, has to decide after getting the instruction, how much material has to come from this tank, and all, because he will know the assays which I said yesterday. Based on that, how much has to be blended, and blended one will go to the particular unit. It is that. So this is their operation. It is there is a sequence controller here. Based on all these things, they will decide how much has to go from which tank. And of course, it will be done by the pumps and different control mechanisms are there because of that. And it's a very dynamic one because they will be receiving into the tank and going pumping. So normally they may not do that, but if the situation warrants, they will have to do. And another thing is each tank, suppose for example, crude tank, it has to be water free. The crude has to be water free. Otherwise, the water enters the crude tank, crude unit. It can have big emergencies. So they have to do the water draw. The draining of water is called water draw. All these activities are done in this particular section. I was mentioning about the additives. These are the additives used, oxidation inhibitors. This because when you keep the gasoline, it can form gum formation due to some oxidation effect. So they use the inhibitor. So the market, you are not getting that problem because the inhibitors are added with additives. Otherwise, what will happen? It will choke the fuel injection mechanisms. Then corrosion inhibitors, which they are also used, and corrosion inhibitors are used in the process plants also to avoid corrosion. And the metal deactivators, well, they are the chelating agents. They, because the hydrocarbon sometimes brings copper and nickel, and they can have adverse effect on the engines, car or vehicle. So they add this to deactivate those things. So these are all added. And emulsifier, again, they are added to avoid any emulsification of gasoline. Mainly, these additives are used as for gasoline, but they are used for other purposes also. Anti-knock compounds, which already told, they increase the anti-knock quality of gasoline. The olden day ages, they were using tetraethyl TEL, but now it is banned because TEL is not good for human beings, and it's an environmental problem, so it is dropped. So to overcome that, they use other means. Anti-icing additives, this is not normally used in India because you don't get that temperature, low temperature. And dyes are used usually to distinguish the batches. When the batch, when the one batch of say 1,000 barrels goes, the manufacturer will like to know which what was the batch, because if any problem comes from there, they can easily identify. Same thing for the markers. Here in the markers, I can tell one thing for the dyes also. The kerosene was issued for public distribution in the ration shops. Previously, what was happening? A lot of adulteration was happening because the kerosene and diesel, they are the distillation ranges are almost same. So, because the ration shops were selling at a low pressure, low cost, the kerosene was getting mixed with diesel. So, to avoid that, the dyes were added, the blue dyes were added in kerosene. So, that's how it got stopped. And I was mentioning yesterday about Bharat Standard 6, all those things. So now government is come out with that. Now many plants are in the process of implementing those things, and these fuels are ultra clean fuels, qualifying to stringent world standard fuel quality. Basically, this is done to improve the environment. That is the whole thing about that. Though the companies have to spend a lot, but the government has imposed because of this consideration. The sulfur content in BS6 fuels has been reduced to 10 ppm from 50 ppm of BS4. So straight away it has gone down. So this is, and another thing is the polyaromatic hydrocarbons pH in diesel fuel have been reduced from 8% to 8% from 11%, thereby reducing carcinogenic, because this is cancer causing. This has got a cancer causing property, so that is there also they have taken care. Now we are coming to power generation and utility and ETP. Power anyway is required, all of you know, to run the refinery. They have some of the refineries, they take power from the electricity board, but because the power supply is not reliable, many refineries have gone for captive power plant, and there they produce steam also, and the fuel what they use can be from the refinery itself, refinery fuel gas they take, or they get natural gas. And in the utility section, they take care of DMW, demineralized water, process cooling water, plant air and instrument air, nitrogen, chemicals, potable water, steam condensate, recovery. All these things they take care, and they supply to all the process plants. And ETP is the effluent treatment plant. They take all the effluents from the units, different various units, and they treat the effluent, and the treated effluent finally, that is the water, they take send it to utility for using in cooling tower, and recovered oil is sent back to unit for further processing. That's how it is. And whatever solid comes, they compress it and sell it. And about the corrosion problems, various corrosion problems are there in the unit, all the units, by means of chlorides, sulfates, of calcium, magnesium, sodium, organic acids, etc. Especially this you would have seen in crude yesterday. The other units also they go through. It's not that the other units are free of this. Maybe in the lesser extent. That's it. The chlorides contribute to overhead corrosion. Sulfates contribute to scaling under deposit corrosion. Other contaminants are mud, sludge, and all. They cause fouling of the heat exchangers. And desalting section removes to a large extent. That's how other units are saved by that. And corrosion combating also is used to chemicals dosing and caustic, ammonia, complex amines, and inhibitors. All these things are used to restrict. And this corrosion is taken care of to a large extent in the design stage itself. For example, in the overhead section, they put monal or maybe other higher grade this one material, that the corrosion effect is minimized. And there is another thing called under deposit corrosion. This normally happens within the insulated, below the insulated portion of the piping, and it may be difficult to check. So they have the inspection pockets continuously wherever they are identified, and they check those things periodically. And if the thickness of the piping is reduced, they project how long it can withstand. Afterwards, they plan it and replace the sections. And these are the things, corrosion happening. Atmospheric tower, naphtha section, overhead section, vacuum furnace again, crude furnace also, it has got where it is expected, and where the total acid number is attack, where they are attacking. All these things are given here. And now we are coming to maintenance. Maintenance is a very important aspect. Without maintenance, refineries cannot function. It's not only operation. Maintenance is equally important. So there are different types. One is mechanical maintenance, electrical, and instrumentation, and inspection. Or they have to work together. And mechanical take care of static, equipment. Under static equipment, columns, vessels, heat exchangers, etc. And rotary pumps, compressors, and other things. There are various types of pumps and compressors. So each and every one has to be maintained. And they have to maintain the record also. When any breakdown comes, they have to record and analyze all these things or the activities they have to do. And accessories like PSV, NRV, steam trap. NRV is non-return valve. Steam trap supports blinds and all. These are all structural coming. So PSVs have to be periodically calibrated. Otherwise, you won't know the integrity of the pressure safety valve. Then, so for that, to maintain the equipments running, we increase the reliability of the equipments. They have to do the preventive maintenance activities because the clear schedule is there. Based on that, they take out the equipment, take it to workshop and bring it back like that. This can happen during the normal operation or during any shutdown also. They have to plan. Same thing for the condition monitoring. They check the vibration of the particular equipment, critical equipment, and all these things are monitored periodically and identified. So they can avoid any breakdowns by that. And they do the periodic calibration checks. And shutdown startup also, they have to plan and execute because during shutdown startup, their activities will be very high and they have to plan with the contractors also. And the electrical, again, captive power plant anyway is there, and the units they have transformers. It can have 3.3 kV or 6.6 kV, depending on the unit. And that is again step down to 440 or to 240 volt. And there is a substation, and they have a lot of motors. All these things are coming under electrical. And they have to avoid any emergency shutdowns. They have UPS, uninterrupted power supply, and the DG sets also. The key equipments will be separate power. So no major damage to the unit. And they take care of earthing, lightning arresters, and all those things. And instrumentation is entire instrumentation is taken care of by this section, and they have a control room, control valves, everything we inside in the unit as well as DCS control room is taken care of by this one. Whatever is preventive maintenance and conditioning monitoring is taking place. Same thing goes for instrumentation and electrical also. And inspection, they check all the pipelines and columns, vessels and all periodically and find out and give reports. And even during shutdown also, they enter the vessel and check each and everything. So this is about that. And special O&M activities, shutdown, unplanned emergency, emergency decontamination and startup, equipment handover, takeover, picking. Picking yesterday I already told, preservation of equipment, chemical cleaning, unplugging or dechoking and flushing, decoking. These are the SADs, steam air decoking. Nowadays in the units, they avoid that, they go for pigging. Documentation is another important thing. You have a lot of PFD, process flow diagram, process piping and instrumentation diagram, PFD block diagrams, and operating manual. SOP is standard operating procedure. CND is cause and effect diagrams, interlog. All these things have to be maintained and periodically and updated also whenever any changes are coming, and they are kept under strict control because they are all the control documents. And HSC and work permits, MSDS, continuous monitoring, end up root cause analysis, because maintenance have to do this root cause analysis any equipment breaks down and find out. And they have to do the corrective actions also periodically. And unit modification, expansion, all these things will have to go through approval. Without approval, nothing can be done. So it's a strict control on all those things. And the plant specific training is given to all the people, operation, whether it is operation or maintenance, whoever it is. Even the contractors are also given training and assist, because without that, there was no surety whether the person can do the job. That's why the assessments are very important. And periodic retraining also is effective. And the same way, shift operation monitoring, corrective actions, shift changeover, all these things are part of the document, because they have to record each and every activity and monitor, and they go through and recheck everything was normal or not. And a lot of audits take place, various safety audits, emergency audits, preparedness, level 1, 2, 3, that is emergency preparedness, the quality checks and all those things. Now we are moving to safety, health safety and environment and fire. Safety is divided into two sections. One is occupational safety and process safety. In the occupational safety, you have safety manual monitoring, behavioral based safety, falls, trips, all these things are coming under occupational safety. Normally, they are connected with a single individual or one or two individuals. And the damage or this one is limited here. But activities are more, definitely no one can afford to have any injury. That is the whole thing about that. So working at high confined space, catalyst, chemical handling, toxic gases, because so many toxic gases, H2S, oxygen. Oxygen, though it is not toxic, but it is dangerous. Nitrogen is a silent killer, H2 is a silent killer, carbon monoxide, carbon dioxide. Carbon monoxide is carcinogenic again. It can curdle the blood if it is inhaled. Then CO2, people will die. And ammonia, chlorine, everything is in the problem. All these things have to be handled very carefully. And the electrical hazards anyway, shocks, all those things. And even static electricity also is a big hazard in the petrocarbon industries. And working on slope or excavation and working with tools like welding, cutting, drilling, gasketing, etc. Radiography, photography, even with taking photograph also can cause electric spark. So like all of you must have heard about the mobile using mobile in the petrol station, just like that. And risk analysis, work permit procedures, issue, validity, closure, authorization, protocols, etc. All these things are strictly monitored. Plus PPE is a personal protection, protective equipment, like hand gloves, safety helmet, safety shoes, and all those things. And there are some special protective equipments are there, which are kept in the unit when there is a necessity. That time they use. I was telling about the process safety. Process safety, under the process safety, there is some element, process safety management elements are there. There are different elements identified by OSHA, the American Institute, and OASD. This is our Indian this one. They have identified these elements, and process hazard analysis, PHA. So the refineries have to comply with all these things. So that's why all these restrictions are put. And control measures before the accident and after the accident. So if it is before, the accident, there are certain things taken care. That is, they do that analysis as of FEMA, AMI, FMEA, FDA, ETA, yeah, that event tree analysis, fault tree analysis, what if checklists. So different studies are made, and SIL studies, safety integrity level studies, and QRA, quality risk analysis. So this will go through, and if the accident has taken place, after that, then they will do the root cause analysis. And health also is checked periodically. The resident doctors, they check the health of the individuals who are working, periodic health checks, general health checks, blood test, respiration, heart, eye test, hearing, heat test, all these things. They recommend, and they have to go for treatment if required. Occupational safety, already I told. Under the process safety, you have equipment malfunction, high or low pressure, because these are all the process safety. Why it is important? Because if some accident happens due to process safety, then the damage will be very severe. It is not only to the individual, the plant can get affected, or it may affect the nearby plants, or it may affect the outside the boundary. So that way it becomes, depending on the severity of the accident, this is all quite possible. That is why it is given very high importance. And this is basically pertaining to the process or operation and maintenance, we can say. So equipment, it can be due to equipment malfunction, or in the process you have high or low pressure, temperature, level, hydrocarbon leaks, or toxic gas leak. All these things are possible during the processes when the unit is running, and the unit upsets, internal or unit activity, shutdown, startup, unit emergencies, all these things. Because of these reasons, anything can happen in the process. So that time you have to be more vigilant, and not to allow the situation to go out of control. That is very important. Should be able to contain the severity, and it may lead to fire. Suppose if it happens, then there has to be emergency response and the control plan. You should not be waiting till then, so you should be prepared. So that's why this emergency response and control plan also is important. With all this preparedness, an impact on outside the refinery premises. So the company people, they have contact with outsiders. They educate them also. It is not only the employees and contractors. They educate the public, because they have to be made aware what can happen, so they will not get panicky. So about the environment, as we have already seen, environment is can be on the causing problems on the ground, or it can be due to liquid water or air. It can be anywhere it is possible. So pollutants can be toxic gas clouds, or asphyxiates, flammable fluids, hazardous liquid spills, or corrosive substances and combustible dust. For example, the oil hydrocarbon falls on the ground, bare ground. Ground gets filled soaked with the ground hydrocarbon oil, that nothing will grow. Or if the hydrocarbon falls into the water, sea, so fishes and marine will die. So like that. So this is an environmental issue. So they have to be tackled carefully. Similarly, if the furnaces, they throw sulfur dioxide, nitrogen oxide day in and day out. So if there is no monitoring, if they are because the pollution control has put some stipulations and restrictions. Beyond that, if they release, then it can be an environmental disaster. So continuously they are monitored. Same thing goes for ground also. Already I told. So all these things continuously are monitored, and the government bodies also visit the refineries and check the records whether they are all monitored correctly. Otherwise, they put heavy penalty or sometimes they shut down the plants. So that is the thing. So liquid water, whatever waste is coming, it can be of three types: solid waste, liquid waste, and gaseous waste. They have to be handled in a normal standard way. You cannot be just throwing the waste. And disposal of waste and monitoring, even if the waste is generated, it cannot be thrown out. You have to bury it in the proper standard way and close it. It is that. So there is a burial ground also nominated, identified in the refineries. And the Pollution Control Board, PCB's norms. The Pollution Control Board is handled by central government as well as state boards also. Each one has their own stipulations and effluent monitoring and control and documentation. So as I already told, all these things have to be recorded and documented also, and they have to be preserved for further audits. And there are again periodic audits by quality control people. The environment also is part of that. IMS is that. And with the fire and fire protection, fire basics, fire triangle, all of you know, oxygen, fuel, and heat source. They form a triangle, and then only fire can catch. Other, if you take out one, there cannot be any fire. That is the simple thing. And fire can be of any due to any reason. In the refinery atmosphere, anything is possible because they handle hydrocarbon. So a lot of counteractive measures are taken. The fire can be of different types: BLEVE, boiling liquid, expanding, vapor explosion, or combustible, or explosion, fireball, fire cloud explosion, or flammable. So there are different varieties of fires. Each one has to be handled differently, the standard way. So the protection mechanisms and devices, there are a number of protection devices are there. Inside the plant, you will see hydrants, then hoses, then fighting nozzles. There is one thing. Plus, there is a regular fire station is there. That operators are trained, and they do the mock drill. Everything goes there, and they visit the plants also, and they do the rescue operation. So MCP is a manual call point. SCBA is that emergency air cylinder. In case they want to rescue a person where there is a hydrocarbon or any toxic gas, they can wear this with a breathing apparatus, and they go there and rescue the person. For the time limit, maybe about 20 to 25 minutes. Within that time, they have to go there, bring the person, so they can save. So like that, there are methods available, and they are trained for that. And reporting, again, manual call point is there through the refineries. If somebody finds any emergency, they have to press the glass, and immediately message indication goes to the fire control room, and they take the action immediately. Within 4 to 5 minutes, they come to the particular spot and start the corrective actions. The training anyway, I already told. Protocols, ERCP is part of fire only, which I already told this, the previous slide. Now, cause and effect. The accidents, why they happen, it can be due to, they may be man-made or by methods or machine or measurement or material or other nature, which for which you don't have any control. So, man blind to consequence, he doesn't know or he may not realize, or overconfidence, or he doesn't know how to communicate, or there is an error, or motivation level, maybe lethargic, or training or skill levels. There are different reasons due to which this accidents can happen. Similarly, for method, they may be using wrong method, water or air ingress, process safeguards error, or right code not used, or SOPs and SMPs, standard maintenance practice, are inadequate. That means the procedures are not up to the requirement. And similarly in machines, worn out over time, that is used for more than the required this one, so it got worn out and run beyond the limits. Or I suppose 100% means they may run it 110%, 125%. Actually, machine cannot take that load. Offset alignment, if there is any offset, the alignment is off, again can give problem. Process change or upset. So this is all possible. And in the measurement again, faulty reading, missing data, and process range not captured. This is again coming to process only. And in the material, defective or poor selection of material, instead of, or they may go for lesser material. Suppose if this one is telling, stipulation is telling 5 chromium, they may have selected 3 chromium and running the equipment at a temperature nominated for or identified for 5 chromium. Actually, the material cannot take that much, so it will get damaged. So that's the thing he's talking about. And natural calamities, it can be earthquake or cyclone, by anything. So for which you won't have any control. Because of all these reasons, incidents are happening. And when that happens, then it can lead to human loss, human life, or it may affect the surroundings, environmental problems, or rather a property loss also. That can be exposure, or you cannot use that equipment forever, like that. It's a real loss. So in different ways, there's a problem. And not only that, if that happens, if it is a major one, the reputation of the company also is at stake, because immediately the rating comes down. So there are many reasons for all these things. And these are the different major accidents happened in India. You can just go through. And specifically, I have marked very simple reason, spark from the Jeep, that has caused problems. In it, 3 or 4 places I have marked spark from Jeep. That is really loading gantry, spark from Jeep, and that has caused a fire. The Merox unit, spark from Jeep, LPG drain was not closed, that time it caused explosion. And naphtha again, spark from Jeep, like that. Very manual human intervention also is very important in all those things. And some places you will find the water was there, so due to that, or air is increased, ingress into the equipment, there was an explosion or fire, like that. So next slide, you'll see some of the cases where your accidents. So what can go wrong? So equipment or line isolation, there are so many reasons due to which things can go wrong. I have identified, listed about 10 only. There are still 55 more. So anyone, due to any reason, these things can happen. Equipment and line isolation, temperature, pressure, flow or reverse flow, level, water, vacuum, steam, heat or reformer related issues, post management and corrosion plus 55. So these are some of the accidents took place. Air eliminator internal explosion because fuel oil air eliminator and filter were being brought back into service. Both vessels were full of air, and this all as fuel oil was introduced, air was compressed, so temperatures increased, and there was an explosion. And bottom one, internal explosion. Compressor started with the air, with the hydrocarbon. So naturally, it will cause explosion. And atmospheric pipe still safety valves, they got open because water entered into the water was not drained before taking hydrocarbon crude into the column. So it caused high pressure inside the column and the safety valve got open. And it was in those days, the safety valves were open to atmosphere. So it was throwing oil. But nowadays, we take it, they take care, and that is connected to flare. So that way they have taken care nowadays. But in the olden days, it was not like that. And during startup, APL bottom pumper on was commissioned. Shortly afterwards, APS tower safety valves lifted. So 3-meter length of pipe above check valve on pump discharge had not been drained of water. This is one of the main causes in many of the startups, because if they don't check it, then they land in problem like this. Not only this incident, there are many incidences like this. It happened in crude unit, in FCC also in India some years back it has happened, and 3 people died. And the vapor cloud explosion, this happened in 2006 in one of the US refineries, because the bottom level control was closed and they did not know, and there was a chain of events took place, and they, without checking, they went ahead with the startup because it was on the startup mode actually. Finally, it came out through this particular thing and spewed out very light hydrocarbon, and the vehicle was taking this one starting. So due to the spark, the entire thing, the refinery got blown out. So 15 people died in this accident. And you can see the amount of damage it has created. So pipe still fire during this naphtha splitter was filled up. This is the thing what I was talking about. This is against the startup. It was due to during startup, FCC unstabilized naphtha was sent from deoxygenated to floating roof tank. So this was very light material. The tank cannot take that much light material, and the tank lid got blown off. But this sort of incident happened in other refineries also. It's not something new. Many refineries, they experienced such a problem. And this is another thing, regenerator, fluidized catalytic cracking unit. And they were starting during startup or FCC, low riser temperature ESD bypassed, and water feed temperature reactor fell with hydrocarbon carryover to regenerator, and after burning after burning occurred and regenerated and damage to cyclones, premium no flow. In the FCC, one of the main dangerous things is reversal. Actually, the catalyst should flow from regenerator to reactor and from the reactor to regenerator. If it is reverse, then you have a lot of problem because oil can enter into regenerator already very high temperature is there with a lot of air, it will blow off. So this is one of the major things in the concerns in FCC. They are very careful about this. The reverse flow exactly is what happened here. And this the last one is the boiler explosion. And this boiler was operating at a pressure of about 120 kg, very high pressure boiler. And these operators, they did some mistake. During startup, they had to use the diesel and they had to use this particular flow path. This is a fuel line. They have to, because a lot of controls are there, you can see, and they have to use, but because the diesel was not lighting, they thought, okay, they can bypass and take it, and they paid a very heavy price for that. Entire this one boiler got blown out. This is the final end result. So that's what happened. So refineries are there for our use. Yes, definitely. They are very useful. But at the same time, they have to be handled very carefully. Now, come to the end of this particular presentation. Now, if anyone wants to ask questions, please ask.
Thank you, sir. Thank you for such a detailed and insightful session. Now we'll move on to the Q&A part. So if you have questions, I've already posted the link in the chat. You can post your questions there or you can just unmute and ask. So first we will address the questions that was posted in the link. So first question, in caulking unit, how the process parameters are decided?
See, it is depending on the design. One is the design, and second one is the market demand. How much gasoline is required, how much gas oil is required. Based on that, they decide. But they cannot vary so much on that because units have to run within narrow band. So that's how it is. It is all depending on the marketing requirements and availability.
Okay, sir. Next question is, what is the difference between light oil and heavy oil obtained in petroleum products?
Light oil is in the range of naphtha, kerosene, and up to diesel. And below that, whatever comes, the gas oils, and they are coming under heavy oil range. In fact, one more this one was there, black oil and white oil. So US people used to tell that is whatever is black is obviously there are other things are coming under white oil.
Okay, sir. Next is what conditions are used for cracking process?
Cracking, I already told, high temperature and maybe less pressure, depending on that.
What is mercaptites?
Huh?
Mercaptites. It spells.
Yeah. One hydrocarbon molecule combined with the thiol, SH. So when it comes, that is called mercaptan.
What is decant oils at the bottom of separator in fluidized catalytic cracking unit?
Fluidized catalytic cracking unit, the fractionator, whatever bottom comes, it is having very heavy oil and is having more ash content. And that can be used for furnace, for firing in furnaces and other places. It's a very heavy oil. Yes.
Yes, sir. What is the motive of Merox process?
Merox is for sweetening the hydrocarbon like propane, butane, LPG. They all have sulfur, and that sulfur has to be removed because that cannot be marketed. So, and moreover, it's environmentally not safe. So that's the reason they use this methodology.
Why sourness sulfur content of crude varies region to region?
The sour crudes, they have yesterday in the this one I said more sulfur means it is they are called sour, and same thing goes for the products also.
In Claas process plant, we have used multiple preheater and condenser. Can't we get the sulfur by using single preheater and condenser?
See, the efficiency of one matters. So you can, if you have multiple, and it is easy to handle, and the temperature also can be graded. In one single shot is getting, you may not have that efficiency. That's the reason they go for different. It's all different design aspects. It's nothing. We cannot decide on those things. The designer has decided, and for the convenience, yes.
Yes, sir. What are the types of corrosion available in refineries?
Corrosion is caused by sulfur or other compounds. It can be nitrous oxide, sulfur dioxide, or many other inorganic oils, hydrocarbons, acids. They all cause corrosion. And salts also, because they also they suppose if salt brings sodium chloride, the sodium chloride disintegrates and forms hydrochloric acid. That also can cause. There are so many reasons due to which corrosion takes place. Sometimes the reactions also take place. Polyethylenic acid, again, the material is held for a longer time with water, the polyethylenic acids start forming, and that can start cracking or damage the vessels. So that's why vessels have to be preserved.
What is the difference between SAD and pigging? Which one do we prefer and why?
Okay, steamer decoking is one of the processes. It is quite good, but the risk is why it is not preferred, because inside the coil coke is there. They put air specifically and heat it. The coke inside the coil is allowed to burn and taken out. So the carbon dioxide comes out and they measure. So that monitoring is very, very stringent. And if by chance any mistake happens, the coil can burn out and it can be a big damage to the furnace, and they have to replace the coil rather. It's a very costly thing, and the production loss is there. So many refineries have experience, because in those days pigging was not available in India and maybe other places also. Once the pigging technology got improved and established, most of them have done away with the steam air decoking. Otherwise, it's a good process, but risks are quite heavy there.
What is the U/S and D/S unit upsets in process safety?
I didn't catch your point. What is it?
What is U/S and D/S unit upsets in process safety?
U/S.
Yeah.
What is it? I don't get it.
Can whoever has written this question, can you just clarify? Can you unmute yourself and clarify? By the time we'll move to the next question, sir. What is hydrocracking treatment?
Hydrocracking.
Yeah.
Hydrocracking is like a hydrotreater only, but operated at a high pressure.
How is overhead pressure and IBP related in a distillation column?
Okay. If you increase the overhead pressure, then the vapor, lighter material which is coming up, it will get suppressed. So when the draw, this from the side draw, you will get lighter, reasonably lighter product. That is how the initial boiling point gets reduced. If you pull more by keeping the overhead pressure, then more heavier vapors come. So so initial boiling point can increase. That is one thing. Second thing is final boiling point also can increase because you are taking more heavy material from the bottom. But it all depends on the column operation because a lot of this one, each section has got a pump around and internal reflex also. They adjust that so that the column profile is maintained. That is very important. They have to maintain the column profile in the sense, maintain the pressure drop across the column, bottom to top, as well as between each section, they have to maintain the delta T temperature. So top temperature and bottom temperature have to be maintained. In addition to that, between each section, the temperatures also have to be monitored. So these things give a lot of information, whether the trays are getting fouled up or how the distillation process is taking place. This is all indicating that. So this monitoring is the continuous operation.
Okay, sir. In FCC process, which catalysts are used?
Silica alumina.
How
But actually, what is the ingredient, you will not know because it's a proprietary item. And different manufacturers are there, they sell. So we will not know the exact composition.
Okay, sir. How the lead susceptibility is determined and why? And which categories of gasoline has the highest lead susceptibility?
No, I didn't catch the point. What is it?
How the lead susceptibility is determined and why? And which categories of gasoline has the highest lead susceptibility?
No, I don't understand this question.
Whoever written this question, can you just clarify in the chat?
See, the gasoline coming from coker, I was mentioning that gasoline coming from coker, it is not that good compared to the gasoline coming out from the FCC, because FCC produces more chained products, broken chains. So they have more value, and that ultimately they are blended together, and finally you will get the proper octane number given by the government. So finally, it is not only one stream gasoline. They have to blend gasoline from different units and get the required product. Of course, they have to inject anti-knocking material and all those things, additives. And there the alkylation unit comes into the picture, because by adding that isooctane, they have the flexibility to get that material.
Thank you, sir. So any more questions, guys? You can ask your questions in chat also. Or if you want to just unmute yourself, you can ask like that.
Hello, am I audible?
Yeah, you're audible. You can ask.
Good evening, ma'am. Good evening, sir.
Yeah.
Sir, in process safety slides, there is a term U by S and D by S unit offsets. What is that, sir?
U by S, let me check.
And D by S in process safety slide.
Also safety. Also safety. Okay. That is upstream and downstream. The upstream means suppose your unit is there, FCC. Upstream is it can be hydrotreater unit or it can be coker, whatever it is. So that is upstream unit, the thing before your unit. And downstream unit is where you are supplying, like a propylene unit or alkylation unit, like that. So it is upstream and downstream, nothing else. So suppose your unit gets upset, and it can affect your upstream units also as well as downstream units also, because from the upstream unit you are getting the feed. Okay, so suddenly you stop, then that unit is running. So where they will throw, where they will send the material. So that's a big problem for them also. And probably they may be receiving certain things from this unit also. So again, there can be emergencies. Same way happens for downstream unit. They are getting the supply, feed supply. Suddenly it is stopped, and the whole operation will go into problem. That's the reason I said upstream and downstream units. So both of them can get affected.
Thank you, sir.
Thank you for the question. Any more questions, guys? You can ask your doubts. Sir is here to clear all your doubts. So please ask if you have any, or you can just put in chat. Sir, what is FCCU flow path?
What is it? ST?
FCCU flow path.
FCC flow path. You get the feed and goes to the, it is getting heated up and coming to about 470 to 500 degree temperature and enters the reactor. From the reactor, the cracking takes place, and after cracking, the cracked hydrocarbon enters the fractionator, and there it is getting distilled. It's a distillation column, that is fractional distillation column. And as this reaction is taking place in the reactor, in the presence of catalyst, coke gets deposited. That the catalyst having the coke, deposited coke, becomes inactive. So it has to be activated again. So it goes to the regenerator, and there the coke gets burnt. The presence of oxygen at a high temperature, and that activated catalyst again comes back to the reactor. It's a cyclic action. I hope you understood. And the flue gas, whatever is going out from the regenerator, that contains some catalyst that gets captured. Plus, that flue gas is very high at a very high temperature, so the heat is recovered. So anything else?
Hope your doubt was clear.
Yeah.
One more, sir, 1 second. What is the best process for increasing the octane number?
There is no single process by this one. You have to blend it to get the product, this one, because different units provide, due to different processes, you get different grades of octane number. So you have to use this one. You have to blend the gasoline to get the product, this one. As for the octane number, unless you blend it in the proper proportion, you will not get. And you have to add isooctane to get it, because as I said, it is ranging, isooctane has got the octane number ranging from 85 to 95. That's the range I remember I have given. So the market, whatever gasoline you get, the octane number is 87. So easily they can play around. And there is one more premium petrol available, that is 92 octane. So by adding more iso-octane, they can get that. So that's why they can easily play around.
Thank you for the questions. I hope all the questions have been addressed. Any more questions, guys? You can unmute yourself and ask. If not, we will wrap the session. I'm just sharing today's session PPT in the chat. The same has been shared in the WhatsApp group. So you can download it from here, or you'll find it in the WhatsApp group. Also, thank you so much, Srinivasan sir, for such a detailed session. I hope everyone was able to gain a lot of learnings from this session. So tomorrow you'll be having assessment of this module from 11 to 11:30. Make sure all of you attend the assessment. Tomorrow we'll start with the new module, process flow diagrams. So I request everyone to join tomorrow's session by 5. So thank you, sir. We'll wrap the session.
Thank you, madam. Thank you.
Thank you, sir. Thank you, everyone, for your active participation.
Yeah. Thank you. Thank you all.